Hello, this is Ollie from Nana Nofro and this is the second part of my little series on explaining my code, and I'm going to talk about my organization. So this is my code now, and compared to my early season code, which is just one big main.cpp file with all my stuff, all my functions, all my autons, and whatever. I want to talk about how I organized for my world's code and my state's code so that it's a lot easier to work with and a lot clearer to explain. So instead of having everything on the main.cpp, I use header files, which instead of having all my autons here, I just put them on autons.cpp, and in here it has all of them, and I just include the header file for that. And I do that for all of them. Okay, cool. Header file's done. Okay, namespaces. So if I want to run something, for example, I want to run my ring sort. I have a namespace for it, because if I want to also run my auto clamp, I have another one for that. And if I want to run both, I can't just have like one function name run, because I don't know if it's okay. Is it for ring sort? Is it for auto clamp? And so inside of my files, let's see, I have a namespace that essentially makes all of the functions inside of it like a part of the autons namespace. So that just makes it a lot clearer if I want to see, okay, what can I do with my ring sort? I can do ring sort, enable, disable, all of these things. And then also just clarifies when you're looking at my main.cpp file, what refers to what. So, and of course objects work as well. Objects are probably better. I'll probably move to those where you make like each subsystem, like the intake, the goal clamp, whatever subsystem in that, you do like intake dot instead of the colon. And so for document formatting, it's best to have it simple and easy. So if you right click, you can do format document, and mine's already formatted, but that just makes it look nice to have that for all my files, as well as of course have comments throughout your code. That should be pretty fair. And of course, in my main.cpp, I don't have that, but the names of the functions should explain that. And if you actually like go to them, okay, not this one. Where's my comments? The comments are somewhere. Okay, and for devices, now this is something I do that's pretty unique, where with your robot and your driving or your controller, you have to move around the ports and move around the like controls a lot. So what I do is, instead of like when I set up my devices, I don't say motor left one on the drivetrain is on port 12. I put that as an enum, or this is part of the namespace, is the enum, where it refers to here, and it says, okay, left one port, and then it checks this enum to see, okay, what's that port on. So that way, if I want to change the port for a motor in the code, I don't have to go looking for all the places where it's called. I can just go here, and this is all very centralized, and I can move stuff around. And actually, the only thing that I changed between like when I moved from my state spot to my world spot was, or if I was like testing the robot, I could just very easily just move the ports around and everything worked. And the same is for this button map, where I would just, in the code, I would call like LB forward button. And this is very easy. This is very helpful, because there's a lot of different places where I would call these buttons. So having all of them go route back to this one place is very helpful. And this actually helped out at the Auburn scrim I went to before Worlds, because someone wanted to drive my robot for a match, or my state spot, so I could very easily change these to have the controls to what they're used to. Okay, and so if you go to our main.cpp file, initially when I had like ring sort and hook on jam and print to the controller, print to the brain screen, all of these different tasks that run in the background, it used a lot of power and my robot would die very, very, very quickly. So what I did to combat that was I run everything I have this object thing, task handler, where essentially there's all these processes that need to run in the background, but I check if they need to run in the background, and I do that with this pull function that runs in the main thread. And if it deems that we need to run the background, then it will make that task that runs in the background. Once it's done, it'll quit it. And that way, it was able to save a lot more power than just like 5 threads running in the background, constantly checking. And I can also print on the brain screen to see what is running as well, which is very helpful. And so as well, I create these tasks that loop during Auton and Driver that just constantly pull for like printing on the brain screen, and during Auton it's ring sort, hook on jam, and they automatically terminate because it checks are we in Auton, are we disabled, etc. And this way it's just a very simple way of choosing what tasks are running during Auton and when you're disabled. Okay, and so for our Auton selector, okay, so initially I had it where I just uploaded everything to a different slot on the controller, but I found it's a lot easier if you just have everything on one file, because I don't like going through and uploading to every single, or like updating every single code if I change something that's not an Auton that we need to change for like the code for Java control or something. So I use Robodash, and this is what our selector looks like, and this just says like what function to run if I select this Auton. So we have the colors, and we have like what the actual Auton is. What it does is we check the first character of each Auton, and then we get the color from that. And if it's S, that means it's just like it's red essentially, because it scales. And then as well, when we assign them here, the reason that we like run a function, use this function to run another function, is because for elims we run our ring stack Auton, but we pass the parameter of elims as true. So that way, at the very end, we have like a alternate ending to rush to the corner instead of to touch the ladder. Okay, so also for in our Autons file, we have, although it could pretty much be anywhere, we have, instead of using like the built-in controls to like move the intake or set the goal clamp, I just made my own functions to do that, because it's a lot more streamlined. And specifically for pistons, some of our pistons were in a way such that if I want to clamp a goal, I would have to, so if I want to clamp a goal like set true, you think, okay, I'm gonna hold on to a goal that way, but really if you set the values true, it'll unclamp it if you just do like clamp dot set value. So this way it just like made more sense if I just made my own functions, and if I ever change the configuration of the hardware and how the piston and solenoid are, I can just change it in the code here, while the intention of my code, how I use it, is still the same. And for my intake, I got kind of tired of just doing like intake dot move velocity, so I did it where spin intake, because I always do like max velocity, but I can plug in parameters to change it. And so what I did was I said like which stage am I moving, am I going forwards or backwards on RPM, but these are not necessary. If I just do like spin stage 1, it'll go intake at full speed. Okay, and of course I talked about this on my first video, just a basic introduction, but having GitHub source control is very, very, very helpful. It's just organized. It's like the definition of organization. But yeah, thanks for watching this video. On the next video, I'm going to talk about how my specific tasks work, such as auto clamp or my color sort, which I finally like made a good one for Worlds, and DC detect and stuff like that. So thanks for watching.